It's written in white normally, so it's hard to see, but there's a dot right there as well. You got to remember to use product rule. Slope is the derivative of the first times the second plus the first times the derivative of the second. In the denominator, you're going to do derivative of the first times the second plus the first times the derivative of the second. So watch out for product rule here. Okay, so mistake number one, not a lot of people are making anymore because I made a big stink about it. I don't think you're just doing y prime to find slope. I think you now know that with parametrics, you got to do dy dt over dx dt to find slope. Mistake number two, they forget product rule. Watch out to make sure you don't forget product rule. Mistake number three is right now. Put 0 in here. That's mistake number 3. Don't put in 0. This is a t value. This is not t. T is not 0. You're not putting 0 in for all the t's. That's the one that weirds people out the most. Sir?
You wrote that as dx over dy. Yeah. Or dx dt over dy dt.
Oh, did I?
Yeah.
That's because I put the x on the top, didn't I? All right, well, let's just fix that real quick. Yeah. Okay. All right, so what we have now, slope is cosine t plus t sine t over sine t minus t cosine t. Is that now correct then?
Yes.
All right. So the point was 0 and negative pi. And the equations were x is equal to t cosine, t sine, and y is equal to t cosine. Here's the thing. We have to find the perfect t value that hits this point. This is an x value. This is a y value. So what we want to do is take that right here. 0 equals t sine t. I got to figure out what t value creates a 0. There's an infinite number of t values that will make this thing equal to 0. The easiest, of course, is let t equal 0. However, if you let t equal pi, it also works. Because the sine of pi is 0. Pi times sine of pi will give me 0. 2 pi works. Sine of 2 pi is 0. So 2 pi times sine of 2 pi gives me 0. 3 pi works. 4 pi works. 5 pi works. There's lots of answers here. If you take the idea of t equals 0, put it into here, you're going to get 0 times the sine of 0, which is 0. Yay. But if you try y of 0, you're going to be disappointed. Because 0 times the cosine of 0 is 0. Boo. Didn't work. So we'll try something else. This didn't work. Let's try that. See what happens. If you do if you do x of pi, you're going to get pi times sine of pi. That's pi times 0, which is 0. Yay. If you try y of pi, you're going to get pi times the cosine of pi. By the way, cosine of pi, negative 1. Ooh, look at that. That equals negative pi. So pi is a great choice. Pi gives you the 0 that we need. It also gives you the negative pi we need. At time pi, the point is 0, negative pi. Let's try the other ones though. What happens if you try 2 pi? X of 2 pi will give you 0, but y of 2 pi is going to give you 2 pi times the cosine of 2 pi. That's 2 pi times 1, which is 2 pi. Boo. Here's the thing. If you look at times 0, pi, 2 pi, 3 pi, 4 pi, etc., the points that are kicked out by the set of parametric equations are as follows. 0, 0, 0, negative pi. This one's going to kick out 0, 2 pi. This one's going to kick out 0, negative 3 pi. This one kicks out 0, 4 pi. 0, negative 5 pi, 0, 6 pi, 0, negative 7 pi, 0, 8 pi, off to infinity. So this set of parametric equations is kind of doing funky things, but that's how parametric equations kind of tend to work. It's actually spiraling. It gives me 0, 0. So it goes 0, 0, 0, negative pi, 0, 2 pi, 0, negative 3 pi, 0, 4 pi, 0, negative 5 pi. It's a spiral, I think. You have to graph it and see. What are we trying to do? Who asked me this? I've lost track. Oh, equation of a tangent line. I got a little off track. Because that's the part usually people get confused about. This is the key moment, once you found out that, because the slope at t equals pi is now going to be, and I forgot what it was. Way up here somewhere. Cosine plus t sine. Cosine plus t sine over, probably sine minus t cosine. Sine minus t cosine. Stick pi's in everywhere. Cosine of pi is negative 1. Sine of pi is 0. Sine of pi is 0. Cosine of pi is negative 1. I'm getting negative 1 over pi as the slope. So final answer is y minus y1 equals mx minus x1. That's negative 1 over pi. So y plus pi equals negative 1 over pi x. There's nothing too hard about this problem. It's hard, nothing too hard about this problem. Jay?
I think our derivative is wrong.
Oh, bummers. I trusted Ben. It's Ben's fault. Okay. By the way, we did the derivative like an hour and a half ago. You could have helped me on that. But okay, here's the thing. I originally did this, which I was told was upside down because it is. I did dx dt over dy dt because that's on top, which is always dangerous about these things. If I do a derivative of t, I get 1. I don't do this because I did derivative of the first times the second. And I'm going to do plus the first. The derivative of sine is positive cosine. Is that the part you had a problem with?
Isn't there a derivative down there?
Okay. All I'm saying is I based that on this. So if this is wrong, that's going to be wrong. What's wrong here? So the derivative of the first times the second plus the first times the derivative of sine. This should be a positive right here. On the bottom, I do derivative of the first times the second plus the first. Derivative of that should be this. So that means when I flip it upside down, it goes like that, which means this happens down here. Is that what you're telling me? Okay. Again, something we could have fixed a long time ago. That's not the hard part of the problem. That's just the part I screwed up. Next request. Yeah.
3.5 number 23.
3.5, number 23. Go.
Find the derivative of y equals r over square root r squared plus 1.
R squared plus 1, you said?
Yeah.
Okay. Some people elect to rewrite this as r times quantity of r squared plus 1 to the negative 1/2, and they do product rule instead. I do not recommend this. I think it makes it harder. You can do it. It is possible. I'm going to recommend you do it this other way instead. This other way being quotient rule. Ho. D high minus pi d ho. All right. The derivative of a square root. The derivative of something to the 1/2 is 1/2 that's something to the negative 1/2. That something I was talking about is an r squared plus 1. So the derivative of r squared plus 1 to the 1/2 is 1/2 r squared plus 1 to the negative 1/2. However, chain rule says you can't just ignore r squared plus 1. I'm now going to take a derivative of r squared plus 1. And I'm going to divide by ho ho. Questions at this time? Calculus is done. The rest of this is all simplification. And that's actually the hard part here. You can't just leave this. You have to simplify within reason. Y prime is equal to the square root of r squared plus 1 minus, now there's some stuff that's kind of easy to see here, the half and the 2 cancel. That's no problem. But what people have trouble with is this whole negative exponent-y thing. I created the negative exponent myself. I'm going to put it back to the way it used to be. A negative exponent is really r over r squared plus 1 to the positive 1/2. I can do that. But eventually, people with large sticks are going to kill me, so I need to go back to radicals.
Yeah, it is.
So r times r squared plus 1 to the negative 1/2 really is r over square root r squared plus 1. What some people try to do, and this would be wrong, they say if you have r squared plus 1 to the negative 1/2 power, you can take that thing and move it downstairs as a positive 1/2 power. So I would bring the 1/2 down as well and erase that little negative. That doesn't quite work. I'll erase the negative by hiding it in the black. Okay. Anyway, that doesn't work. And the reason it doesn't work is because you just killed a puppy. You don't get to slide stuff up and down through fraction bars. People do it without thinking about why they're doing it. There is no magic trick. There's no rule in math that says you just move stuff up and down as much as you want. There's a thing you're doing. People lose track of the thing they're doing. And this guy right here is the reason you can't do the thing you're trying to do. Subtraction signs and addition signs tend to destroy lives and kill puppies. So watch out for that. Here is what you should do instead. Instead of doing a magic trick, understand what's actually happening. What's actually happening is you have something to the negative 1/2 power. By definition, that is 1 over that thing to the positive 1/2 power. This. Question quick.
It's r squared. The numerator of the thing, right?
Is it?
Yeah.
Did he tell me that?
No. R and 2 R.
Because that changes a lot of things.
No, you multiply the 2 r's.
This
Not
is r
that-
squared.
No.
That's what you said.
No, you messed up.
I agree with you. I could have messed up, but you said the numerators
R
are
and the 2
Help
R's.
me out. All right.
After the subtraction
D
sign.
high minus high D ho.
That one, right there,
1/2
that R. That one. From the 2 R, the R from
You want me to square that?
No.
That's what you keep telling me. That's why I'm really confused. So I'm going to start to redo it
Can
again.
you just go to the derivative? And then after the
The
subtraction
derivative of
sign.
r squared plus 1 is 2r.
Okay, the one.
And down
yeah.
here is r squared.
Yeah.
Okay, so anyway. You can see how it's a little confusing when you say the top is r, because there's lots of r's at the tops. Okay, now, down to here. R squared plus 1. You have a square root inside of a denominator, which is not necessarily bad by itself, but a fraction inside of a fraction really is. You're not simplified within reason right here. You have to keep going. And the easiest way to get rid of this is to multiply by that. You do that to the top and you do that to the bottom, it really works out nicely. These will cancel. And as an added bonus, it's going to distribute over there and also get rid of that square root. So in this one move, you can make things look really, really pretty. Y prime is now the red square root of r squared plus 1 times this gives you that. These cancel out completely, leaving you a minus r squared. And in the bottom, you have an r squared plus 1, square root of r squared plus 1. Those cancel, and you can see why on this particular problem, there's a lot of simplification to do, and it does make it look quite a bit prettier, so you have to invest that time. The textbook might have gone another step here. I have no idea. They might have rationalized. There's no need to do this. I might have done this. There's no need to do this. I personally do like it. I think it's prettier than this one. But I wouldn't say one of these is worth more points than the other. However, if you leave it like this, you're going to lose points. The r squareds cancel. If you leave it like this is gross. There's fractions inside of fractions. Don't leave it that way. If you leave it like this, it's not simplified. There's all sorts of things to simplify. So simplify within reason does say you got to go down to here. It's a little weird, those directions. But you got to keep going until you get to the end. And you don't know where that is unless you've seen it. Okay.
And you leave your
No, because the people with large sticks will jab at you. Remember that story? Just say yes so we can move on. Okay. I prefer you don't leave it as 1 over r squared plus to the 3/2 power, or r squared plus 1 to the negative 3/2 power, or any of those kinds of variations, only because we're not supposed to do that. I don't think I would take a point off, but I'm not